So today, what we'll try to do today would actually be, for me at least, a quite interesting topic. I would like to show you how you could, for example, build your own simple SQL database. And what we'll be doing today, of course, it's not going to be holistic because of the required intricacies, of course, that has to do with building like a full-fledged functional database. But what we'll do today, more or less, would be to introduce you to the basics to let you understand how things work under the hood and make you aware of them, basically, so that the next time you work with a database like a production grade functional database Postgres, for example, you can begin to appreciate the amount of work that has already gone into build such open source services. So of course, before we dive in, I would like us to maybe talk a little bit about the several components that a typical SQL database normally would have. And over here, I've just created a sample database, sample projects, nothing really happening here, just hello world. And I can also just quickly show you show you we really don't have much. I can say cargo run, and we should simply just get our hello world. Okay, so let's talk a little bit about the basic components of a typical SQL database. So you have, of course, the database schema, which defines the structure of the database. So this would include things like tables, columns, and their data types. So within every database, you have the option to define these components because they have to be unique to a given database. So that's also why you could understand that across the different kind of databases you have out there, they all do not really have a one-to-one mapping when it comes to like the data types, for example. So this is simply because when you design your own database or when you're working on a project where you have to do so, you get to define those data types. So the next component, of course, will be the SQL parser. So the SQL parser is responsible for analyzing and interpreting SQL queries, basically converting them into an internal representation that can be executed by the database engine. And then we have the query executor, which of course does what the name sounds like. So it's responsible for executing so it takes the internal representation of our SQL query and then it performs the necessary operations on the database, things like retrieving, inserting, updating, or deleting data, the very basic, all the operations that are possible within a database. And then you have, of course, for me, the most important part of a database, is, of course, is the storage engine. So this manages the physical storage and retrieval of data on the disk or in memory, again, depending on the kind of database we have or you're working on. So with this high level overview in mind, would like us to dive deeper into the implementation detail. And I have also over here prepared a simple, I'm just going to collapse this now so we have more room and maybe increase the font size so you can be able to read this. So I have prepared a simple, maybe not so simple, but documentation regarding what's really required. This is much more detailed than what I just showed you. So, but of course, the whole idea is the same. So, but within a typical SQL database, you would have the SQL. Maybe I preview this so it looks a lot more interesting. So we have the database schema design. So you have to design the schema of the database. Like we said again, you have to define these tables, what a table means within your database. What is a column? What is a row? What are the possible data types that you can store in your database? This is where you get to define those. Then the next, of course, like I just said a few minutes ago, would be the storage engine, where you define how you would like to physically store this file that you retrieve from person using your database on a physical file management system. So you get to implement this. And then you have your SQL parser, which is also like for me the second most interesting aspect of a database because this is where you talk about lexical analysis, like about parsing, where you also have to come in contact with the abstract syntax tree AST, and you also have your query validation. So you have your query executor, you have optimization, concurrency control, transaction management, and all of that. So I've included all of this here really for knowledge base, and I expect you to, of course, to take your time, go through it. And the point, like I said in the beginning, would not be for you to, of course, go out tomorrow and implement a full-fledged functional database, but the point would be for you to really understand what's and how databases function under the hood, and then you can maybe afterwards begin to appreciate production grade databases. So, but that's really the short intro I wanted to give. Again, if anything is not clear, I'm going to have all of these committed to GitHub, and I will of course leave the link in the description of this video so you can take your own time, go check it out, pull it, whatever, clone it, whatever it is you would want to do, read it up and understand a lot more regarding what we are doing here today. And of course, the code will also be available in case you want something to play around with. So anyways, let's just come in right here and start making some implementations. So the first thing I would like us to do, of course, will be to add the packages we require. So I'm going to open up the terminal here and clear the screen. And now I can easily just add the packages we need. So I can simply say cargo add. And the first thing I would require, of course, will be set, and I would need to add feature. So I can see features, and I'm just going to add derive. And that should, of course, I'm just going to maybe open this up so you also see what we're doing, nothing fancy. And other than that, I would like us to, of course, add bean code. And I'm going to add this and what else do we need? Just for some example I would like to show you, I'm going to also add num. So let's remove this and say num. And that's all the packages I would need us to install. So I'm going to collapse this and then come over here, create a folder. I'm just going to call this DB. And within it, I will create a file. This will be my mod.rs. And then I come to our main package in here to the very top up here. And I can say mod db and I collapse that. And now we can actually come inside this package and start defining the components of our app. So actually, I am adapting this tutorial based off of a project I'm working on. So that's also why I would like to more or less um, focus on actually making you understand how things should work or could be set up, without just dumping like the source code, because I probably also won't be able to just dump the source code, of course, but I would modify the examples and show you. And but again, like I said, the point for me would be for you to understand how this could work. Okay, so that's why I'm really going to keep it quite simple. And of course, for my projects, I'm not really trying to implement a new database. Of course, that would be really futile and time. I would just end up wasting time actually. So, but what I'm trying to do actually requires me to write some amount of data into a file and also have this file encrypted, and of course retrieve the data within this file as efficiently as possible. And of course, I'm implementing this in Rust, but I could have also easily have used say SQLite, but I couldn't because I really needed to encrypt this file. And of course, I also wanted to work with some custom data types. So it's really just boiled down to build something, not really like a full-fledged database, of course, in my own case, but something I would say maybe similar or at least in that direction. Again, not like a fully standalone database, but it serves a purpose. It allows me to store some crazy custom types. It allows me to retrieve and insert data quite efficiently. And I can, of course, encrypt this and have this within the file system where I have, let's say, a server running. So I can mount this on the file system of a server on the Azure cloud. So this is really the use case for me. And that's why I also thought maybe it would make sense for me to share this with you. So anyways, like we said, I'm just going to come over here and create a file. I'm going to call this schema rs. Again, if you remember, if you come back to what we said here, there are several components, and um, this tutorial, I'm not going to touch all of them, but I'm going to touch some of them, actually the important ones, at least the ones that would apply to this simple example I want to show you. So I'm starting off with the schema, and that's also what we're going to do here. Pretty straightforward. So I'm going to come here and define a struct, and I'm going to call this table. And just for IntelliSense, I'm going to come over here and add this, of course, schema. So let's go to schema and now my table. So within the table, I'm just going to add two things. So I can add one called columns. So my columns is going to be quite simple. Again, we are really going to work with just one data type. And for this example, it's just going to be string. So my column can be described as a vector of strings, my columns, and I have rows. For my row is going to be actually a hash map And for the hash map, the key is going to be a usize, and the value is going to be a type I call row, which we have to define down here. So I can come down here again and define a struct, and I call this row. So this is what's going to define my row. It's going to be quite straightforward. I'm just going to have one attribute for now called data. Again, I'm keeping this as simple as possible. So I'm going to have one attribute called data, and that data is again going to be a hash map where the key is going to be a string and the value is also going to be a string. It's going to be as simple as this. I would also like to add some threads on this already. So derive, and here I'm going to add okay, I'm going to leave debug for now, and I would like to add serialize, and I also add the serialize. And what else? I can also maybe add partial equal. I'm going to add clone. I'm going to add equal. So of course, these ones, additional ones, are just going to allow me to do comparison. I'm just going to copy all these threads that we have on the row, and of course put them on our table. Okay, so again, I'm keeping things as simple as possible. So this would of course form the basis of our schema. Again, you can already imagine, if you are, for at least for the project I'm working on, it's a lot more complex than this, but there's really no point to make this that complex. The point again is to make you understand the intricate inner workings of a simple database, simple SQL database. Okay, let's proceed. So that will be off our schema for now. And so I'm going to come over here again. The next thing I would like to implement will be my storage engine. Again, these are all really stripped down just to focus on what we need to do. So I'm going to create a new file here, and I'm going to call this storage engine.rs. And again, I'm just going to bring that in here, pub mod storage engine, and then we go inside that file and start making implementations. So now I'm going to define a struct that's going to represent a very, very simple storage engine. So I'm going to create my struct, and I'm going to, of course, call this storage engine. It's going to be pretty straightforward. For now, it's just going to have one attribute called tables. And those tables, again, I'm going to use a hash map to represent those tables. So the key would be some string, and the value would be a table, actually, as simple as this. So this would define my storage engine. Again, pretty straightforward. Again, I'm going to just come over here, copy these traits. And did I miss out something here? I think I did. No. Okay, I'm going to come over here and add these implementations to our storage engine. You know what, there's no need to do this again. I'm just going to come over here, copy this, come back in here and paste that. Boom, that's sorted out. Okay, so this is going to represent our storage engine, and then down here I would like to have some methods implemented on this struct. So those methods, as you can already imagine, would basically help us to actually perform the actual operations on those physical file systems that would have maybe living within our server, our backend server, as an example. So I'm gonna just come down here and import storage engine. This is again going to be straightforward. I'm going to add a couple of methods. I would like to have a new method that would return a self. And down here, again, it's really going to be straightforward. So I can say storage engine, and I have my tables. And this is going to be, I'm just going to say hash map dot new, new, as simple as that. And other than new, I would like to implement so for this tutorial, we are basically going to just do two things, because I really don't want it to get longer than I expect, because trust me, this can actually get quite long. So I'm just going to allow us to focus on quite two simple things, and those would be to create a table which I think would also be interesting to you. And the next function that I would implement, of course, would be I would like to implement an insert function. So I can say insert row. Again, my storage engine is going to be quite simple, as you can already imagine. Okay, so we have our insert row, and then I would like to implement two more methods. I'm going to call those serialize and deserialize. So I'm going to create a new method, and I'm just going to call this serialize. And the last method I would like to add, of course, as you can already imagine, will be deserialize. So I'm just going to go in now and fill in the components of these different functions. So our create table function is going to take immutable reference to self, and it's going to take a name because we need the name of the table we would like to create. So it's going to be a string, and of course we would have a row, which is going to be of type row, and of course it's not going to return anything actually. So why does this keep popping up? It's not going to return anything. So but what we'll do here is it's going to be quite straightforward. So I'm going to say self dot tables, and then I say dot insert. So for insert, the name the name of course is going to be here. I'm just going to maybe say name dot to string. That's going to be the key. And for the value here of course will be our table. Or actually we really don't need this. So actually we don't need rows here, so this should be columns. Nope, not that. Columns, and here column of course is going to be just to match our definition for columns is going to be a vector of strings. And then so here our name, we've inserted the name, and of course the next thing we would need to insert here will be our table. And now for the table, I'm just going to provide columns, and for our rows would be I'm just gonna do a hash map dot new. So let me undo that. That's not what I want. Hash map dot new. That's really it. Okay, so that's actually all. I'm just gonna bring this down here and maybe close this up. And now this should be fine. So we have some errors down here. So let me see. Field is private. Okay, I'm just gonna go in and make this public. So I'm just gonna go over to table, come down here and make this public, and this one public as well. And now this should be fine. So this is again is gonna be quite straightforward for now. So creating a table basically is just gonna insert a new entry in our hash map. That's really all this is doing for now. Okay, so I have another one called insert row. So again, this is going to take a mutable reference to self. It's going to take a table. I'm just going to explicitly call it table name, and it's going to be of type string. And then of course it's going to take a row, which is going to be of type row. Again, maybe I actually going to keep this. So our insert row is, I'm going to keep it simple for now because normally this should actually return an error. So the insert should either work or not. So, but again, we can also either way, but I'm going to keep it as simple for now. But this should actually be something like this. So say a result. And then in here, we can maybe return nothing if everything goes well, and otherwise we can return some form of error here. And we can also maybe define a custom error. But again, I'm going to keep this as simple as straightforward because I just want us to focus on the main logic. Okay, so I'm going to do a simple insert in our hash map. So I'm going to say if sum, and in here, I'm going to take I need to get back a table. And to get back that table, I'm simply going to do a self.tables.get mutable. Get mute. And for the mute, of course, I'm going to pass the table as the key. And if everything goes well, now I can get my I can try to insert this. I think we call this table name, so I'm gonna have to replace that with this. So, but if everything goes well and we're able to find the table, now I can define a row ID. So row ID would be equal to, I can say, table dot rows, and I can maybe get the length, and then this will give me the length of the ID of the length of the entries in the table already. And now I can simply say a table dot rows dot insert. Come on. Dot insert, and to insert here I'm going to add my row ID, and I'm just going to add row down here, and it's really that straightforward. Of course, due to the numbering which starts from 0, there is really no need for me here to do an increment, so this already should be fine to have the correct ID. So anyways, as simple as this is going to be my insert row. Again, I need to implement these two methods here, and then we are through with our storage engine. So here I take the first argument here is going to be a reference to self, and but other than that, I'm going to need a buffer, and that buffer is really going to be quite simple. It's going to be a mutable reference to a vector of u8. So here would be u8. And in this case, like I was trying to show you in the insert, what you can actually do is to maybe return a result here. And then in this case, for example, if everything goes well, just not going to return anything. But if I encounter an error, I might return an stdio error like this. As simple as this. Is going to be quite straightforward. And now the first thing I can do here is I say buffer dot clear. And when I clear the buffer, now I can say buffer.extend. Where is the extend function? Extend. So, and now this is actually where I use the bin code that we installed initially. So now I can say bin code, and I call the serialize method, and I pass an argument. In this case, the argument I'm going to pass is going to be self. And then, of course, I leave you to do the proper error handling. So anyways, I do my unwrap as a way of me handling the error. And then down here, I simply just return okay. So if everything goes well, we would return at this point. And to deserialize, again, is also going to be quite similar. So again, it's going to take a reference to self because of course it's really part of this implementation. And then down here, I'm going to again take a buffer, which is going to be a reference to a slice of U8. And this is again going to return something quite similar to what we had over here. So I'm probably just going to copy this, come down here and dump that in, and maybe remove this extra space here. And then let's see, expected, of course. Okay, so let's do our implementation. So in here, what I want to do is I'm just going to keep it quite simple. So I can simply call bin code and say deserialize. I call the deserialize method. I pass the buffer, and I handle the error by just calling unwrap, and that's already fine. So I'm keeping it quite simple, but this is the storage engine I would like us to implement. It's going to be as simple as straightforward. That's all the code we'll be needing for now. And then if we need more, of course, I would show you. But so let's keep it as simple as possible. And then we can actually focus on understanding the inner workings of a typical SQL database. So let's proceed. I'm going to come in here, I'll create a new file, and I can call this executor. So this is going to be executor RS. And then I need to, of course, add it here again. So I say pub mod executor, and then that should be fine. So I come in here, and then we can actually start making our implementation. So for our executor, I'm going to create a struct again. I'm just going to call this execution engine. So execution engine like this. And then in here is going to have just one attribute. And I'm just going to call that is the attributes actually it would have would be of type storage engine. So I'm just going to call it, I'm going to name it explicitly. So I say storage engine will be of type storage engine like this. And that's really it. And then I would like to have some implementation on top of our execution engine. So I can come in here, come on, import execution engine. And in here, I'm just, for now, I'm gonna just keep it simple. So I would implement just two functions. One would be like a new method, and the next would be like an execute method. And again, the execute method for now is just gonna do an insert for me. That's it. So I'm gonna come here and create a new function called new. This new function is just gonna take a storage engine. So storage, this guy is not would not be needing to initialize this actually, so it should be passed when a new instance is being created. So I'll pass the storage engine, and of course it should return itself, so it should return its execution engine afterwards. So I put self in here, and then down here now I can have of course our execution engine, and then within this point we simply pass our storage engine. And that's it. So that's our new method. The next implementation I would like us to have here would be, of course, our execute function. So again, it's going to be quite simple. It's going to take as a reference to self, and then it's going to take a reference to what I call a query plan. This query plan is going to be of type. I would have to implement a query plan. So I'm going to come here again, create a new file, and I can call this query .rs. So to actually not go this route, the actual thing I'm supposed to do at this point would be to implement a lexer, like we have down here. So if I can try to find it, I know it's somewhere here. Yeah, so this would really help us to parse our SQL query when they come in. But I'm gonna take a different route, at least for this tutorial. So, but don't be rest assured it's not gonna impact, of course, what I would like to show you here. So you would, in the end, of course, be able to get everything I would expect you to get in here. So I'm gonna come here and I create a struct again. Again, before I do that, I would need to come over here, pub mod query, and then I have my query. So in here, I can define a struct, and I call this query plan like this. And query plan is going to have just two things. It's going to have one thing I call a projection. And this projection is going to be of type, it's going to be a vector, and the vector content would be of type identifier. Identifier like this. And my identifier, again, I'm going to come up here, keep it quite straightforward. So my identifier is going to be something like this. So I can say pub struct identifier. It's going to take a string actually. That's going to be my identifier. And on top of this identifier, I would like to add some implementation. So I need to add some implementation. So I'll say pub derive. So I'm going to have a debug, of course, and then other than that, I'm going to add a partial equal, I'm going to add an equal, and I'm going to add a clone for now. I don't know if I need a hash. I can just keep this here for now. And so this is going to be my query plan, and then here, this is going to be of type query plan like this. Okay, and now maybe I'll just take care of this query here, and then we can, of course, continue with what we're doing. But for our identifier, I would like to implement the from attributes or from threads. So I can say implement from, and I need to provide the type. The type is going to be of type string, and I'll implement this for my identifier like this. It's going to be quite straightforward. And then here I implement a from. So from and to are more or less I could say interchangeable, and if you implement one, you don't need to implement the other. So identifier, and then I simply pass my value, which will be my string. And that's really all I need to do for my identifier. So I can just move over to my query plan. And then from the query plan, I'm going to go ahead and start adding the other attributes. So it's going to also have a table, and the table is going to be of type identifier, like this. And now I would like to have, so now I can actually go ahead and maybe have, let's say, a query planner struct. And now once we actually get to this point, things maybe might become a lot clearer for you. I'm gonna maybe copy all of this, or maybe no, I don't need to. I simply need to add this debug threads here. So that's really what I want to add here. And then so aside my query planner, I will need to have a struct called query planner. For now, I'm just gonna keep it simple. It's gonna be empty. So now I input my query planner. And again, it's gonna be straightforward again. I'm gonna have a pop function called new. That's gonna return a query planner. And then what it's simply gonna do is to just like this again, query planner is gonna be empty. Nothing inside. That's my new method. And aside my new method, I would like to have a function called plan. And plan is going to take a reference to self. And aside that, is going to take another reference, my AST node. So this is me planning, of course, parsing the query that I get, and then to be able to understand the actual content of that query. But for now, I'm just going to keep this open like this. And we would come back later to implement the body, of course. So, but I want us to go back to the executor that we've already started working on and complete this. So inside the execute method, what we will do here would really be straightforward. Again, I would like us to just do just basically two things. So we should be able to create a table, we should be able to make an insertion, and we should be able to retrieve what we've inserted. That's really what I want to show you in this series. If you understand the basics, you can actually extend this. And I will also add some links to some resources for you to read further to understand at least some of the other things and that might, or some possible questions you might already have up until this point. So in here, I would like to instantiate a table. And that table, this would need to, of course, know the table we are working with. So here I can simply say storage engine. So from the storage engine, I can get my tables. 1 second. Okay, so this seems to be private. So I can, let's see, let me see. So let's go to storage engine. Then of course make this guy public. So let's come back here. So now we have our tables, and now I can perform a get. So for this get, I need to pass a key. In this case, I would just like to pass my query plan. So I'm going to pass it, of course, as a reference. So it's a query plan. And then I can say, okay, or so if things doesn't go well, and at this point we have an error, I would like us to handle this error, of course. So for the error, I would like to have a custom error. So I can maybe before we proceed, I'm just going to come down here and implement an error. It's just going to be an enum, and I call this execution error. And for now, I'm just going to allow it to have just one attribute. So I can have say table not found, and it's going to maybe take a string. And this is also how you get to define custom errors that could be possible for your database to actually throw. And for this, I'm also maybe gonna implement or add a thread. So add the derive, and then here I'm just gonna maybe leave debug for now. So when everything doesn't go well, if we have an error, here I can now maybe implement my execution error and say table maybe I zoom out so we have some space, or maybe that's too small. And I say table not found. And in here, I can, of course, so for our custom error here, what I would like to simply return would actually be that identifier. So in here, I can, let me see. So I remove these parts. And now I can actually say query plan, dot table. And of course, I would need that first attribute. So I can simply say dot zero, sorry, not O, zero. And we seem to, so of course the field is private, as you can see over here. So I can simply come over here and make this guy public like this. And now this should be fine. And then, but here also I have to do exactly the same. So I can here say table on dot zero like this. And now I would like to, of course, handle the error. If you see here, we are getting a result as expected. So now I'm going to change the signature of this function. So it's going to have a return type, and that return type would, of course, be a result that could either return a vector of rows, or it could return an execution error like this, as simple as this. So that way, so I need to, of course, maybe import this. So that way here now I can maybe use the question mark operator like this. Okay, and now we have access to the table. So what we would now do is maybe instantiate a result. So now I can say I need a mutable result, which is going to be again a vector, because I know what I'm going to return and it's still going to be a vector. So I just instantiate this like this. And now I can loop through my row. So I can say for row in table that's row, sorry, table that's rows, this one. And I can say that's values. So this is me looping through all the values of the table. And now I can maybe get my data. I can say my data would be, I can call it row data, for example, just to make the name descriptive. So I can say let's mute row data, and then this would be a hash map. So I can say hash map.new. And now what I can easily do would be row data, and I insert. And the key here would be column, let me see. So now of course I need to actually look through my projections. So here I can say for column in my query plan projection. So query plan dot projection. So I'll look through my query plan projections, and now I can actually do an insert. So I can say row data dot insert, and here I would have my column. It's gonna be dot zero, or maybe I'll just clone for now. Dot clone, and my value would be something like this. I can actually say row dot data dot get, and now I pass a reference to my column, the first entry there, so I can say dot zero, and now I can say that's cloned, and I can say unwrap or default, for example, and I close this up. And now when everything is done at this point, I can now say results dot push. And in here, I would just like to create a new row entry. So I have my row this way, and my data, of course, would be my row. Come on, my row data like this. And then in the end, down here, I can just return my results. That's also why we have a lot of this error everywhere. So now this gets out of the way, and now we can actually focus on the problem we have. So let's hover over this and see what the problem is. So it says row is private. That's also fine. So let's go in there and make this guy public. So now this is fixed. So now we've been able, of course, to implement our execution logic. So this should take care of our In this case, for now, this mostly just gonna help us to actually either do an actually basically query and retrieve the data where we will be storing in our database. And normally we should implement this in such a way that we can use it for multiple functions. But for now, I'm just keeping it simple. It should help us to retrieve our data for now. That's really what it's gonna do. So I'm gonna keep this as simple as this for now. And then I'm gonna come in here again. I create a new file and I can call this parser.rs. Again, let's not forget to come back to our mod and bring that in. So I say parser, then we go into the file. And then now I would like to implement a very simple, straightforward parse logic for our of course, our queries. For our parser, I'm going to actually put every logic that has to do with our parsing in here, because again, this is not a full-fledged database, of course, but I'm going to just make things as simple as possible. I'm going to also implement like the tokens in here. I'm going to implement our AST node, and I'll also implement our parser in here in this same file, just to keep things simple and straightforward. Okay, so I'm going to come in here and create an enum, and I'm going to call that token. So this token is really going to be straightforward. So I like to have an attribute called keyword. It's going to take a string, and aside of that, I need one called identifier. Again, it's going to take a string. And if you notice, most of the data types I've been working with are actually strings. Because again, if we are parsing our tokens, we mostly would work with strings. It doesn't really matter, even if, for example, you're building, let's say, some toy language, and if you're building your AST node tree, you would, of course, root the entire file in as a string. So in the end, you would just, of course, be working with strings. So even if you have like 5 plus 5 coming in, you would still have this as a string, then parse it, and of course, then perform the required implementation. So that's why most of the when you're working with tokens, mostly you would actually work with strings. But anyways, I should have one called operator, so it should also take a string. And so other than that, I'm gonna the other things I would take care of in our tokens would be like white space. I would take care of maybe commas. So if we have a comma in our query, I would take care of left paren, parentheses. I'm just going to write that as out completely. So I will take care of right parentheses, and I will take care of EOF. So EOF, of course, will be end of file. And for our token, I would like to have some threads. So derive, I'm going to have debug. I'm going to have, let's say, partial equal. I'm going to have equal. And I'm gonna have clone for now. That's probably all. And so I think that's all the token I would wanna have. And then down here, I'm gonna implement an enum, of course, another enum. So this is gonna be my AST node. My AST node. So in here, this would actually be specific to the possible SQL statements. So things like select, update, insert, create, whatever. And again, I'm going to just focus on maybe one for now. So I would like to handle one called select statement. The select statement is going to, of course, be a struct type, and it's going to have two attributes. So one would be projection. This projection would be a vector of my identifiers like this. And again, it's going to have a table, and this table again would be an identifier like this. And so for now, I think I'm just going to focus on this for now, because again, this is getting longer than I anticipated. So I'm just going to have an identifier down here. Is again going to be take a string, and that's going to be all. So that would be all for my AST node. And then I would like to have another struct down here called parser. Like I told you, I'm going to have all of them within this file because it's getting complex. So I'm going to create another enum. This would actually be my parser. So within the parser, it's going to just have, no, actually, this should be a struct. It's going to be a struct. So this struct is going to have just two attributes. It's going to have tokens. My tokens are going to be of type vector, and the vector is going to be token. The type is going to be token. And so the next thing is going to have, I'm going to just call this current, is going to be a use size, actually. And that's going to be our parser. It's going to be this straightforward, actually. So for the parser, I would like to have some implementations for it. So I can simply come down here and have import parser. And then in here, I'm going to have a bunch of functions. So I'm going to have, of course, one called new. So new is going to take tokens, which is going to be a vector of tokens. And then it should return itself. So it should return a self. It should return a parser. So in here, it's really going to be straightforward. So I can just say parser like this. And then our tokens, of course, would be, I'm simply just going to call this one tokens as well. And current, I'm just going to make this 0 for now for simplicity. So this is going to be new method, and I need a method called parse. Parse is going to again take mutable reference to self, and it's going to return an AST node like this. And in here, I would like to implement a simple, so I need a singular function now. I can call this because like I said, I'm going to just focus on the select statement. So I would like to have a function here called parse select statement like this. Again, it's going to take a mutable reference to self, and should it return something? Yes, maybe also let it return an AST node. So I can say AST node. And in here, I can now simply call self.parse, or come on pub fn, and parse select like this. And now I'm just going to implement something quite straightforward for our parse select. So just to show you a simple example. So maybe what I can simply do is I can use an assert equal here. I think this is just for development purposes. And I can say self dot next token on what is going on. So I need to actually implement a next token function. So I can come down here and have it for, or maybe she doesn't even need to be public. So I'll say fn next token. Again, this is simply going to return a token. So I'm going to say let token is going to be equal to self dot common tokens. Let's see, that's get. So why do we not have this? What is the problem? Of course, it needs to have a reference to, actually a mutable reference to self. So I can say self.tokens.get. And then for the get, I need to provide an index. So here I'm just going to say self.current. And now I can call the cloned function, and I can handle the error. So here I can say unwrap or, and down here, I would like to handle the error. I can maybe handle like end of file error. So here I can say token EOF. So if we encounter any error at this point, I would simply just want to return end of file as the error. And then down here, I'm simply going to say update my current. So I can say self, because this is me now handling the tokens in our AST node actually. So we have, so basically the point is that in here we can have an input, for example, that says select this from some table, say users. And now to parse my select statements, I would be working with this string. So now with my next token function, I expect, of course, the zeroth index, because again, that's also why if you remember, our current is starting at 0. So the zeroth index when I'm parsing this string should be select. That's really the point here. So when it is select, then of course I'm passing the correct statement. So in this case, of course, select statement. And then other than that, I can now take care of the remainder of the statements. So what it means that when we are done and you try to do a delete, for example, or an insert, at least with the current stage where we are, is not going to work, because for now we are only handling select statement. That's really what we are doing here. Okay, so now I can actually increment my current, and then I simply return my token. So that's up here. Now I can say next token, and I call it like this. So I have my I'm still trying to assert basically what the arguments that we got from the user. So I can say token dot keyword, and the keyword here would be select. I simply just convert this to string. So I expect, of course, that at this point, what I'm getting is a select statement. That's really what I'm doing here. This is just for development purposes, actually. So anyways, I need to create my projection. So I can, and it has to be mutable. So I can say let's mute projections, and this would be a new a new empty array of empty vectors, more or less. I can simply say vector.new. And now, why does this keep popping up? And now with our projections, what I can actually do is to loop through our tokens and then try to handle everything. So what we have to do now, of course, would be to loop through the tokens and try to handle every single thing in our token tree. So I'm going to do quite two simple things because I don't want this. If when we handle this, actually, you can understand how this can now get complex. So I can say ident, and this would be coming from, I say, projection. Sorry, I just function now. I say dot push, and now I pass. It's not just going to be a value, so I'm going to pass an identifier. Identifier, and for the identifier, I pass my ident like this. So of course, this should of course be like this. And for this to happen, of course, now we need to loop through our tokens. So we iteratively look through the tokens that has come in as a query. So to do that, of course, is straightforward. We can now simply say self.next token. Again, now we are handling our select statement. So I can cut this and bring this in here. Okay, so in this case, for now, I'm just going to keep it simple. So when we have our token, we simply just go ahead and process it. And when we don't, we'll simply just, maybe if we have a comma, for example, for now, I'm just going to continue. So, but at least you can already imagine what we are doing here. But other than that, I'm just going to break for now. Okay, so what we are really doing is, again, looking through these tokens and parsing the content. And if we get a comma, again, you have to imagine that you have to handle everything in this tree as it comes in. So again, I'm keeping it simple. In the end, we're just going to do a simple query, maybe a select from our database, and that should be able to, should be good enough for us already for testing. Okay, so let's proceed. I'm just going to close this off. So now I can do another assert. Here it's gonna be again straightforward. I'm just gonna copy this, come down here, and I'll try to this time I'll try to assert from, or maybe I also make it like this. So at this point, I'm actually not again paying attention to whether the strings are in uppercase or lowercase. Again, you can already imagine the complexity that would be coming into this, because you have to now consider all these possible scenarios for a user trying to use your database. But for our own case, I'm keeping it simple. I'm expecting that all our queries would be in capital letters. So that's really how simple I'm going to leave it as for now. So down here, I need to get the table. So, and of course, I need to get this table from the query. So we should already have a table called whatever it is you're trying to query from. So I'm just going to come in down here and say let's table, and this table is going to be equal to, I can just say match self dot next token. Again, I'm going to extract this again from your query. So I say token dot identifier, and then the value here again will be ident. And in here, I need I can simply call identifier like this, and then I pass this ident. So when I have this, otherwise, I don't really care about anything else. So here, I can maybe do, or simply just return an error at this point. But for now, I'm just gonna maybe panic, just for me to be able to see what is really going on. And I can simply say expected identifier for 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 the specified table name, something like this. And of course, I have to close this up. So if I have my table, what I can now simply do is, of course, I perform my select statement. So I can say AST node, and I take care of my select statement. And I like to have this in 2 lines. So let's bring that down. So my projection, of course, would be the one I have up there. And my table would also be the one I have here. And that's really it. So this is going to take care of our parsing. Again, we're focusing on just select statements. I keep repeating that just for you to not be able to ask, oh, why do we have just this? So we have this function pass select statement, and the whatever we are doing from our AST node will just be our select statement in. That's going to be our focus, of course. Okay, so at this point, I would like us to be able to now work with our DB file. And if you remember, everything we actually have done so far would just leave our data in memory. So when we make an insert, we really don't have it anywhere. And if we should restart our database, in this case, we really have no data actually. We are not making any inserts on actual file. We are not also reading from an actual file. And that's really bad. So because of that, I'm going to come back to our storage engine. Again, I'm keeping all this related in an actual application, of course, like the one I'm working on. It's a lot more complicated like this. The file structure is also much more complicated. But for this tutorial, that's really not the focus. So that's why I'm also trying to keep everything as simple as possible. So I'm going to come down here and where we have our storage engine implemented, and I'm probably going to create a new struct here, and I can call this file system, something like this. And file system is going to have just 2 things. So it's going to have, maybe I'll make this pub for now. I don't know. I will see if I need to make it pub. So I have a storage engine. Again, it's going to be, of course, of type storage engine. And the next thing, of course, I'm going to have, for now, I'm just going to have one called file path. File path can actually be either of 2 things. It can be a path buff, like you have here. But I'm just gonna keep it simple. I'm just gonna make it a string, because again, just to keep it simple, actually, nothing more. And for our file system, I would like to implement some structs. Okay, so I need to have derive, I need debug. Let's see, I need my partial equal and I need equal. And then down here, I would need to import our file system. Again, pretty straightforward. We're gonna have a new function. This new function is gonna take a file path. I mean, why not? You can actually make it interesting. Let's make this a path buff. Let's make it a path buff. So this is gonna be of type path buff like this. And it should be able to, of course, return a file system. So I'm gonna say self down here. And then in here, what we have to do is quite straightforward. So I'm gonna say initialize the storage engine. So this is going to actually wrap our storage engine. Our file system struct is going to wrap our storage engine. Okay, so I would create a mutable storage engine up here. So let's mute storage engine. And this is of course coming from our storage engine, and we have our new function implemented. So this is really going to help us to keep things handy. And so now I can try to find, so first thing I would like to do is to check if we have this file already created. If we don't, then we should be able to create it. So I can say if path, I'll use this from here, and I say that, let's say new, and this should take, of course, a string. So now I can say file path, and I should be able to say dot into, I think, let me see. Um, Let me see, 1 second. Okay, I think this probably would just accept a string from what I see here. Yeah, it's fine. I'm just gonna keep it simple. So I'm gonna make this, actually I'm just gonna make it a string like this. And I think this should be fine. So when we have our path, what I would like to do, of course, is to check if that file exists. So if it exists, what I will do here is pretty straightforward. I can come here and instantiate my storage engine as this. Storage engine would be, let me see, I can say file system, um, file system, and I can say let's load. Let me see, 1 second. So now, what I would want to do first would actually be to create some helper functions. Those are going to help us to save or load from file. So I'm just going to create two functions I can already imagine. So I'm going to call one called load. I'm going to create one called load from file. Sorry. So load from file. It's going to, of course, take a reference to self, and it's going to take again a file path, which is going to be of type string. And I'm going to make this return a result, actually. Well, why not? So it should be able to return a storage engine, or it should be able to return an stdio error like this. So this is going to be load from file. The next one, of course, would be one that's going to help us actually save to file. So for this is, let's implement this first. It should be quite straightforward. So we can call this file and make it mutable. And now we can say let file dot open. We call the open function. We'll pass the file path. And I'm just going to use this, of course, now because we are returning a result. Now I can actually use the question mark signature to handle our error. So as I call the open function, if everything goes well, I create a new argument, and I can call this buffer. So this buffer is just going to be a new vector slice, actually an empty one. And now what I would like to do would be to, I can say, let's storage engine, because now I'm trying to, of course, return this from here. So I can say let's storage engine. This would come from storage engine this way. And I can call the deserialize method. So I pass, of course, the self, and I pass the buffer. And of course, let me see, let me handle the error. Of course, I'll close this up first, and then we can handle the error actually. Also, what I can actually do here is maybe make this kind of like a static method, more or less. So I'm going to remove these parts, the serialized parts, so that I don't have to refer to this, and then I can now remove the self, and then we can only now, of course, work with the buffer that we are passing to this. But what I can simply do is to pass this by reference like this, and then we can proceed. So our deserialize, so let me look here to see. Actually, it's not returning the right thing, it's just returning nothing. So I'm just going to change this to self so that it can return, of course, the storage engine itself. So that's really what I want to have down here. Okay, so once I have access to the storage engine, of course, and now down here, what I can simply do is to just return the storage engine like this, and this should be fine. And let me see, actually, these ones now do not need to be mutable. So let me see. So right now we have this file argument. Why I added this here is I wanted to show you so that this point, this is actually where I do additional things, at least with the implementation I have. At this point, I can actually, let's say, do some file decryption, because I will of course need to decrypt the file, because in my own case this file is encrypted, so I first need to decrypt this file, and when I've read what I need to read, I can also of course do the handle the encryption again. So that's why this argument in here, because of course it's actually quite handy, but that's really the point. Okay, so now I create a new function and I'm just going to call this save to file. It's going to actually do something quite similar to the one we have up there. In its case, it's going to again return a result. Actually, the results, if everything goes well, we actually won't return anything. But if something goes bad, this is actually when we return an IO error like this. And so what we need to do here is actually pretty straightforward. So I'm going to create a file that is mutable. And I can say, I can use the open options from std from the standard library. So I can simply call open functions dot new, call the new method, and then of course it's built using the builder pattern, as you can already imagine. So I can just call the write function like this, and I can say I really want to make it right, so I set that to true, and then I say create, and I set that to true as well, and I call the truncate function like this, and I also set that to true if I can type. And now finally I call the open function, and now I simply of course pass this from path from this struct itself, and then I can simply say that self, and of course it returns a result. So I handle it this way. So it's, if anything goes bad, again it's going to be an stdio error. So this question mark, of course, because we are the signature return type of our function is a result. That's also why we are able to actually use this question mark signature. That's really the point. So anyways, when we have our file, what I would want to do now, of course, again, is to create a buffer. So I'm going to say again, so let mutable, I call this again buffer. And this again is going to be an empty slice. So I can simply say vector.new. So I create a new empty vector. And now here I can simply say storage engine, and I can call the serialize method, and I pass the buffer. But in this case, I would like to pass a reference to the buffer. And again, I handle the error. And let's see, we seem to have another error. So let me see. Again, I'm again just going to make it quite similar to this one. So it's going to be more or less like a static method, actually. Okay, so let's see one more time. We still have some errors, so let me see. It's not satisfied. Actually, this should be having self, so I'm just going to leave that, but maybe I make this immutable, and yeah, that should fix it actually. So now we have our storage engine initialize this way, of course, by serializing the contents of the file that we've read. And now the last thing I can simply do is to maybe come down here and now and call, say, file.write all, and this is save to file. So I simply call write all, and then I'm just going to pass a reference to our buffer. And again, I handle the error like this, and this keeps popping up. And if everything goes well at this point, I simply return OK. So that's really one thing I would like to implement here. So now we have the methods to be able to load from file, and of course to also save to file. So now I can come up to our file system or up here, and now I can call the load from file function. And for this, I would need to, so let me see. So load from file. Again, load from file. I'm just gonna make this, of course, like a static function. And now I can get rid of this part as well, so that we can simply just pass the file path to it. And now up here, I can call the unwrap method, and I can simply say unwrap or. So if we actually get, if we're not able to read, I'm simply just gonna create a new storage engine instance like this. Okay, so that's really what I would like to do here. And now down here, we can simply call our file sys common. Nope, that's not what I want. File system like this, and now we simply pass the arguments we need. So we need our storage engine, and then we need our file path. So here I'm just going to say a file path dot to string like this. And let's see what is the error. So expected path buff. Again, I'm just going to change this one to keep it simple, so I'm going to just change this to string for now, and that should be fine. So that would be our new method. And other than that, I would like to create also a corresponding function. It's going to be a public function, so I'm going to make it public, and I'm just going to call this create table. Again, it's going to take immutable reference to self, and it's going to take a name. And name again is going to be is of type string, and then again it's going to take columns, and the columns is going to be a vector of strings like this. And I'm keeping this simple, I'm not returning anything, but of course you should. So now I can simply call the storage engine like this, and I say create table, and I pass the arguments, the name and the columns like this. And then other than that, I would like to, of course, in this case, simply save to file, and I call the unwrap function as well to handle the error. So that's really simple as that. I would have also gone ahead to implement a lexer, but this is really getting quite longer than I would expect. So I'm just going to try to use what we have right now to come to our main file and then try to bring everything together to see where we are. So inside our main file, I'm going to come in here, and I'll just simply call our file system. And I can simply simply call the new method. So I can say file system.new, and I provide a path. So I would like to have a file in our root called database.db. And of course, this should return a file system for me. So I can call this file system equal to this. And now what I would like to do is to just go ahead and do some insertions. So I can say file system dot insert Do we have an insert method implemented? I don't think so. So again, we go back in here and we try to implement an insert function. And actually, I think we do. Let me see. No, we actually don't. So let's go ahead and implement one. It's going to be, I'm going to make this quite simple. So I create a new function and I call this insert row. Again, it's going to take a mutable reference to self, and it's going to actually take a table name, which is going to be a string, and it's again going to take a row, which is going to be of type row. And it's going to do something quite straightforward. So I'm going to call this storage engine, and then I say create, no, not create table. Now I need to call the insert row method. So I'm going to just pass the table name and the row like this. And come on. And of course, I would like to update my file. So I can simply call this save to file function. And then I call the unwrap method. As simple as this, go away. So I come back in here and I call the insert row. And for the insert row, I'm just gonna do like a quite simple operation. And for this, I'm probably just gonna create a table called, I don't know, maybe one called users. And so in here, I'm just gonna create one called users. And for the rows, I'm gonna of course use the row struct like this. To provide the attributes. So I can call, it has a data attribute and this data has to be a vector. So I'm going to use this guy. And in here, I would provide my attributes. So in here, I can just pass my ID. And I'm going to maybe make this to string, of course. And then maybe I separate this with commas actually. And then I'm just going to maybe give it an ID of 1. Again, convert this to string. I'm probably just going to copy this because I will be repeating myself a lot. And so I have an ID. I need a name. So a name. And after the name, I need to provide some name. And here I can say Anthony 10 like this. And then I provide the value. And then the last thing, of course, I would provide would be email. Again, I convert this to string. And then the value would be Anthony.18 at gmail.com, for example. Again, I convert this to string. And let's see. And here, of course, I need to maybe do something like into ether to convert this an iterator. And of course, I collect. Okay, and now we have, of course, our data that we want to insert. Okay, so right now I have my data and I can really come down here and then add my statement. So my statement is going to be something like this. I'm probably just going to call this input. And for this, again, remember, now I'm only handling, my query is going to be in all caps. So I can say select all from my users table like this. So now I can try to pass this argument and I can maybe give it a name. So this is going to be our AST token tree, and then this is going to come from our parser struct, and I simply call the parse method, and this should be able to, of course, return 2 things for us. And what we get back is actually a result. So I'm just going to unwrap this, and so now we have our AST node. And now, so at this point, of course, what I would want to do would be to prepare my query planner. So I can say query planner, and this will come from my query planner. And I simply call the new method to instantiate this. And then with the query planner, what I can now do is to create a plan. So I say query, I can say call it explicitly query plan. And this, I can use my query planner and I call the plan method, on it. And then I pass, of course, a reference our AST as we have defined. And then I have a plan. So with this plan, what I can now do is to, of course, instantiate our execution engine. So I hope this is not overwhelming. So execution engine, and this will come from, of course, the execution engine. Again, I call the new method, but of course this needs our storage engine to be already created. But this can of course come from our file system, so I can call our file system, and I pass the storage engine. And maybe what I can even do is to just clone this, for example, just for simplicity. And then we have our execution engine. Now what I can actually do is to actually execute this query and then expect the results. So I can select results, and the result would come from execution engine, and I call execute. And then I pass, of course, the query plan, and then I handle the error like this. And then at this point, of course, we should get our results. And now what we can actually do is maybe print line this, and I can simply say the result, something like this. And of course, this is going to be a vector, so we can display it like this. I can say result. For example, so but if you notice, we are actually trying to make an insert without actually, we've never created this table before. So what I can actually now do is to try to, of course, run this query and see what we're going to get. So I can simply say cargo run, and then let's see what's actually happens. So if you see, we actually get this error down here, and that's the value of the error actually says table not found, because we actually never created this table in the first place. And this is of course what we expect to happen. So what we can now quickly do is to just create the table and then see if we can make an insert. Okay, so but we can quickly do that. I can come up here and say file systems, and I can call the create the table function. I name it users, and then I provide the vector for columns, and then of course I'm expecting this as strings. So I have ID, which I need to convert to string. I'm just going to copy this because I'm going to repeat myself severally. So I have ID, I have name, and last but not the least, I have email. And now we have all our columns. We've created the table, and now we can try to insert. And of course, right now our table does not have a way to, we have not implemented a way to, of course, continue reading from what we've created initially. I would have to, of course, delete this table. If we try to open with the content, of course, you would also see more or less nothing. So I'm just going to come here and delete this table. So we try to do that one more time. So let me run this again. And then we see, and now we also actually see out here, you see the outputs of the content. And then if I try to view this one more time, of course, we can't really show what's there, but because it's really difficult to view SQL files locally, of course, unless you have the right tools. But if you look here, you actually see what we have. So you can also see the content, and you can also see the outputs. The only difference right now is that we are not returning the correct information. We are actually just returning these projections. So if I go back to this execute, this is actually what we are printing on the screen, which is also what you see here. So rows is just this, and projections is the identifier. That's also what we have here. So of course we can make modifications to make sure that we're actually getting these rows down to the user, of course, when you execute this query. But again, the point was that we were able to create our table, create a table, of course, for users, make an insertion, and we are also able to read this content after the insertion. And what we can also actually do is to maybe come here and do another insertion. So I can maybe copy this, come here, and maybe change this to 2. And now here I can change the name to, I don't know, just reverse this, for example, and call this Anthony. And then also remove this part, and as I reverse this one as well. And maybe also delete the table. Again, we are not taking care of this again. And now I run this query one more time. And then you also see here that we get the two attributes. So the first one, of course, tells us um, this is the row, and of course the second one is this also the second row. So to also verify that this is actually coming from the database, all we can simply do is to maybe try to actually read from the database without doing all these parts, and then see actually what we get. So now we try to run this again. Again, remember right now we just have our file system created this way, but we are not executing this part of the code. So we are not creating any table, we are not reading any, we are not making any insertion, we are simply just executing our query. So if I run this again, cargo run, now you see we still get our file. Again, just also to show you this is not being hard coded actually. Again, I can just show you one more time, I can delete this, comment this part out. Come on, I comment this out and run our query, and it will make the insertions for us. And now I close this up again. So I comment this out and execute the query one more time, and we should still get our content. So guys, that's really what I wanted to show you. If you come back to the things we had in the README, we tried to, of course, show you how you could define the database schema, define the storage engine, talked about SQL parsers and queries, and we talked about the executor. Maybe I preview this so we can see it nice better. So we talked about these executors, and of course, we didn't get into the nitty-gritty, like things like this query optimization, concurrency, control, and stuff like that. Some of the points, of course, which we had initially at the beginning of this tutorial, I think we achieved, which was to really show you the inner workings of a simple SQL database, how it works, how it's set up, and how you can actually more or less implement one just for the fun of it. And guys, again, just to make this not get longer than expected, we definitely have to draw the curtains here. Thanks everyone, of course, has been part of the journey. And this might have been a mouthful, I can guess. So feel free to watch at your own pace. Feel free to reach out to ask questions. I would really love to answer them as much as I can. And for the ones I can't, of course, I will try to point you to the right directions, provide you the right documentation so you can also read up. But again, the point is to of this channel, of course, is more or less to demystify some of the topics regarding software development, just so you understand that it's when you understand the underlying basics, every other thing will definitely fall into place. Anyway, guys, that will be all for now. And yeah, if you're new to the channel, you definitely know what you have to do. Just subscribe and hit the notification bell, and then you will be notified each time we have a new content for you. That will be all for now, guys. And until we see each other.